Welcome to the last video on linear regression. We're going to use Microsoft Excel to do all the heavy lifting for us. I'm going to show you all of the various outputs that you'll get from Excel in this PowerPoint. And then I will quickly open up Microsoft Excel and walk you through where I got all of this output so you can see how to get it yourself. So first up, we're just going to work with our simple, easy example. That only has 5 data points. It's easy to enter into Excel, so you can play around with this as I go through it as well in the next part of this video. But when you enter in this data set, you can create the scatter plot. You can get your line of best fit using Microsoft Excel. And then you can also run a regression data analysis that gives you the summary output over here. Now, the summary output should have some values that are already familiar to you from the other previous recordings. So take a minute and look at it and see which ones are ones that you're very familiar with. Okay, so multiple R, that first row underneath the regression statistics output, that is the correlation coefficient. We get it right away from the output generated by Excel. Underneath that is R squared. Remember, R squared, I said, was this coefficient of determination. And that tells you how well the variability is explained by your model. The other two values we're not going to worry about here. And the last one just tells you how many dots are on your scatter plot. Those are the points in your data set. Those are the XY combinations. So in this case, there are 5 dots on our scatter diagram. So the number of observations is 5. So now that we know it is a positive linear correlation based on this correlation coefficient, now we can get our least squares line. So in here, there's more output generated by Microsoft Excel at the bottom here, this table. And as you can see here, we have y hat equals 2.688x minus 2.44. And as you can see in this table, we have coefficients, intercept, x variable 1. So the intercept is the intercept, and the x variable 1 is our slope. And the difference here is that the ones in the equation for the line above are rounded. The ones in the table are not rounded. There's a lot more information to the right of that, saying how strong these values are in terms of prediction. But you'll get to that in a higher level statistics course. In this one, we just want to be able to create the least squares regression line to model our data. So that is sufficient for now. The next slide is not truly necessary, but it's kind of informative about all of the other calculations we did. So let's just take a look at it for fun. So the ANOVA that's generated and the residual output that's generated, those two middle tables for this data, also have the residuals. So the sum of the square of the residuals is in there that we calculated. The residuals separately and the predicted values are also available in Excel. It has all of those listed out. So if you're looking for predicted values of y that go with the x's that were provided in the data, you get that out. But fundamentally, the previous 2 slides are sufficient for creating a model that will help you deal with other data that might not be within your data set. Now let's do the fun part and actually open up Excel, start clicking and pointing on graphs, getting some of this output generated so that you can use it to complete all the work in linear regression without struggling with all of the computational nuances of this. Now let's play around in Excel. So in Excel, I've already entered the data set here. So what we want to try to do is first, we're going to try to create a graph. So we're going to highlight our data, the X and Y values, and we're going to go to Insert. And up here, we have all of these different options for plots. Which one looks like the one that we want? This says XY scatter. It has the dots on it. We'll just select that. And we immediately get a graph of our data. So this should look like what you saw in the slideshow. We can dress it up a little bit more. But what we really want to do is we want to get a graph with the line of best fit. So when we go, I don't want to do that too fast. You're in this graph. If you click on the graph, you'll see here quick layout. So quick layout is where the magic will happen. And there's 2 ones with lines. There's this one and this one. You're going to want the one that says f sub x. That means that it's going to create a function. It's going to give you your model. So if you click on that, it will include right here the line of best fit. And it'll tell you here it's linear. And we can grab just that and move it over. It's usually easier to see if it's not on top of the graph. You can also move this to a different sheet if you want. There's lots of ways you could edit and refine the graph, but this is sufficient for our purposes. You can double click on the axes to give them titles. So we're going to call this X. I'm going to double click on this. We'll call this one Y. And the title, made up data. So if you double click on any of those, you can clean up your graph and make it look pretty. But there it is. We have our prediction line. We have R squared, which matches all of the things that we had on that slide deck. And I did it in, let's see, 1, 2, 3, 4 clicks. And I have all the information I need. Now, remember, I also had all of that other output. How did I get that? So the other output is really great for future statistics courses. So I want you to be aware of its existence so that you know you can get to it. So if you highlight your X and Y data again and go to data, over on the far right, there's this data analysis button. And if you click on that, it gives you several options. There's actually a lot of good stuff in here that we will be getting to. But right now we want regression, because that's what we're doing. We're doing linear regression. And if we go to OK, it tells us to select our Y. So we're going to click here and we're going to select our Y values. You could also enter the cells since we know how to do that. Maybe I'll do that for the next one. And here we're going to do X. So here I'm going to go for X values. It's easy to click on this because then it lets you highlight and drag. So I click and I drag and I get the values I need. Then I hit the little button there again. And that allows me to get this window. I'll just drop it in a new worksheet. That's fine. If you want a whole bunch of other things, you can click on these, but the output should be sufficient as is. So if we click on OK, then we get, let me zoom in here. So there's all of the different tables that I showed you in the PowerPoint. We have the multiple R, that's our correlation coefficient. We have our coefficient of determination, number of observations. We have our sum of the squares of the residuals, so sum of the squares of residuals. And we have the coefficients for our prediction line. And that's all you need from this data at this point. All of this other fancy stuff over here will be useful in the future, but we don't need that as of yet. I did not click on the residuals or the residual plots. If you wanted to see all those calculations of the residuals, you could do that. I think it makes this less tidy, so I wanted to avoid that. I hope this was helpful, and I'll see you tomorrow.